Okay, let's get ready to go again. It takes time for the conductor loop to rotate 1 revolution at least. The time it takes for that conductor to rotate 1 revolution and to produce this waveform is referred to as the periodic time. If you allow me just to clear any drawings as such and go back with the writing, it gives a bit more room. The periodic time. Periodic time. Otherwise represented as a big T or a capital T. Thus, if 50 cycles are produced in 1 second, how much time will it take to produce 1 cycle? Or the frequency, as you can see in the diagram. Well, let's clear that. It must mean if 50 cycles are produced in 1 second, that 1 cycle, or the frequency that you can see in that diagram, must be produced in 1/50th of a second. So every cycle, 1 cycle, must be produced in 1/50th of a second. You can make a note to that effect if you wish. And if we can get Ben just to describe periodic time in relation or in terms of 50 cycles per second. Do that now. Thank you. Okay, well done, Ben. Let's move on. Still considering this diagram, you can see that the maximum EMF, excellent, is at this point where the AC waveform starts to rise to its maximum potential, or maximum EMF. EMF standing for electric motive force. Well done. In other words, voltage. We've only displayed 1 volt to make things simple in this diagram. We call that the maximum peak of the waveform, the maximum peak of the waveform, P-E-A-K, I want that up there for you, peak of the waveform, the amplitude. The amplitude of the wave. Okay, let's continue that very, very quickly down in that direction to that point there, just to finish that half of the waveform off, which is of course the positive or the negative side. Excellent, the positive. We'll do the same and we'll represent that on the bottom of the waveform, like so. And we'll put the point in the middle of the negative half of the waveform. Do that so on your diagrams now. Okay, you'll notice one distinctive characteristic of that waveform. And if we follow the peaks down to the horizontal axis at 90 degrees positive, and then of course 90 degrees negative, we can see 2 points, one there, and obviously one there, like so. If we manage to join them 2 points together like so, and that one like so, we refer to them 2 peaks, positive and negative. Which peaks? positive and negative, well done, as the peak to peak voltage. The peak to peak voltage. You can make a note to that effect. Peak to peak voltage. I'll just clear my writing very, very quickly. Peak to peak voltage. Let's have Daniel, describe peak to peak voltage. Okay, it's the maximum voltage or the peak of the waveform on the plus side and the peak of the waveform on the negative side. Jack, Glennon, describe that very, very quickly. Peak to peak voltage. Okay, superb. Question for Jack Griffiths, since we haven't included him just yet. That formula there, EP minus P, represents what do you think then? EP minus P. Okay, it does refer to the peak to peak voltage or the electromotive force from peak to peak. One side being the plus and one side being the minus. EP minus P, standing for, whole group, electromotive force, peak positive and peak negative. Peak to peak voltage. Okay, let's get rid of that. Let's see what we've got. We've got some notes coming up for you again once more. You should have these already, so we'll skip through them very, very quickly. And amplitude. If you can give a heading in your workbook somewhere, the amplitude. Okay, let's see what we've got. I've got a feeling there's some notes coming up for you. I'll read out from the board very, very quickly. The time taken for the waveform to complete one cycle is called the periodic time. Well, hopefully you should have them notes down already. If not, now's your opportunity to take them down. The time taken for the waveform to complete one cycle is called the periodic time. Okay, if 50 cycles are generated in 1 second, then one cycle must be generated in 1/50th of a second. Well, we've already identified that, but I'll read it out one more time for the purpose of your notes if you wish to take them down. If 50 cycles are generated in 1 second, if 50 cycles are generated in 1 second, then one cycle must be generated in 1/50th of a second. That's 1/50. Okay, let's see what else we've got. The maximum value of the EMF in one cycle has been shown, rather, by the peak value or the amplitude. Well, that's the maximum voltage of the waveform. In the waveform that we've just drawn, the maximum voltage or the peak voltage was what? Let's have a Jack Griffiths again, one more time. If Jack said 1 volt in either direction, plus or minus, yes, Jack, you were right. Well done. 3 bullet points. I'll read them out one more time very quickly for the purpose of your notes. The time taken for the waveform to complete one cycle is called the periodic time, T. Bullet point number 2, if 50 cycles are generated in 1 second, then one cycle must be generated in 1/50th of a second. Bullet point number 3, the maximum value of the EMF in one cycle is shown by the peak value or the amplitude. Okay, I've got a feeling there's another one for you coming up. Bullet point number 4, the voltage measured between the positive and negative peaks is called the peak-to-peak value or the peak-to-peak voltage, whichever you prefer. So bullet point number 4, the voltage measured between the positive and negative peaks is called the peak-to-peak value or voltage. Okay, let's see what else we've got. If you can give a heading very quickly, angular velocity and frequency.